Okay, everyone, thank you very much. Thank you for your patience for this initial setup here, and welcome to this talk about removing security roadblocks to IoT deployment success. My name is Eustace Asangawa. I'm Security Program Manager for the Azure IoT Platform team, and I'll be co-presenting with Thorsten Stein. Want to introduce yourself?
I'm a Senior Program Manager on the Windows IoT team, responsible there for cybersecurity, and I will share this talk together with Eustace.
Awesome, awesome. So thank you for being here. We are very happy to have you here. Throughout this talk, hopefully the message that we can convey to you is that Microsoft is leading the charge on securing IoT around the world. And that in order to get to deployment success, there are certain roadblocks that get in the way, some that Microsoft can solve, some that the community needs to come together and solve together. And what we hope to show by the end of the presentation is what Microsoft is doing in order to remove the roadblocks. So to start out, we all know in order to secure IoT, security has to go it has to be end-to-end. From devices, the connectivity, and all the way to the cloud. So I'll start with the simplest portion, the connectivity portion. On the connectivity, the industry is very comfortable with what it takes to secure a connection from one endpoint to another. The standards that govern this communication, secured communication, TLS, using identities based on X.509 certificates, they have been around for a long time. So we will not be spending a lot of time on the connectivity portion, but the message to you is that every connection to Azure IoT is done through a secure connection using these standards. On the cloud side, Microsoft has done and is doing a lot of investment because that is where Microsoft can really lead the charge and make decisions in securing the cloud. There are many ways in securing the cloud, and there are many ways of measuring this. One of the few ways that I want to share with you is through compliance certifications. So if you look at compliance certifications, the diligence that it takes in order to maintain a secure cloud, Microsoft has one of the most expansive compliance for any cloud provider in the world. Okay? This is saying that to Microsoft, security is not an afterthought. They design for it from the ground up. They put in the diligence that is needed in order to get a secure cloud infrastructure. And it's not just the compliance. Let's look at what the public sees about that. So more than 90% of Fortune 500 use Azure IoT Cloud. We see that as an endorsement onto the work that Microsoft is doing towards the cloud. So with that, I hope you can trust us or trust the Fortune 500s that Microsoft is doing what it's needed in order to secure the cloud. So now that leaves devices, and that is where we all come in because all of us have choices to make there. What device do we want to use in order to secure IoT? What steps do we want to take in order to make sure that the devices are deployed and operating securely? So for that is something that Microsoft cannot do alone, because there are other inputs to that equation, like costs, like diligence, like operational details that has to come from the deployment, the people doing the deployment on them. But what Microsoft has done in this area is gathered its experience over so many years and done research to find out what makes a secure device. And these are published under the 7 properties of highly secure devices. So these are measurable properties that you need to have in IoT devices in order to have confidence that the device will hold up its own end in security. So when you look across these properties, there are properties that are very hardware-centric and hardware-dependent. There are properties that are software. And then there are aspects of it that is operationally, like renewable security on there. One way to condense these 3 aspects is to look at security as this amalgamation of a root of trust in hardware, having the right integrity in the operating platform, the operating system, and the software that runs on it, and also cloud services. So these are things that needs to happen in order to have a secure device. So what is Microsoft doing in order to help out with this? Starting with the root of trust, going the other direction. Starting with the root of trust, embedding trust in hardware requires a special kind of silicon hardware. Just any hardware will not be able to hold up if somebody were attacking the device to get information out of it. So we refer to this as secure silicon. Sometimes some people call it hardware secure modules. And this comes from silicon providers, semiconductor manufacturers. It takes special processes to manufacture silicon that can withstand an attack coming from somebody. Okay? So Microsoft is working with silicon providers in order to enable the use of their products onto the Microsoft cloud securely. And Microsoft is working with standards. There are standards out there that define how some of these secure silicon work in order to make sure that those standards operate with the Microsoft cloud. And then you have the software aspects. Touching the metal, touching the device is a software set that Microsoft defines in the form of Azure IoT SDKs. We build these SDKs to be usable by everybody. And how can we do that? We provide a lot of choices and flexibility on there. So you have a choice of language. The SDK is offered in several languages. We don't tell you what operating system to use. You choose what operating system you want to use. And then we have an hardware abstraction layer on the SDK. So this is the way that you can layer on any of the secure silicon that is coming from the secure silicon vendors. And most of all, you have the renewable aspects of the security built into the SDK. So it will assist in updates, in renewal, in certificate renewal on the system. So we put a lot of engineering into these SDKs in order for it to deliver quality, in order for it to make sure that your security story, it continues to hold up through updates and renewals. And then finally, you have the renewable aspects of the security, which is services that over time, when you deploy your devices, you can use these services in order to update your security story on there. So on Azure Cloud, one of the main ingress points of information to Azure is Azure IoT Hub. And this comes with security controls on there. You have services on there for IoT, like device management, device provisioning service. And Windows as an operating system did not start with IoT. It started with enterprise. So over 20 years, there is a lot of experience from the Windows operating system and operating platform on how to operate enterprise networks securely. And all of that information is built into securing IoT today. So let's see how IoT Hub offers security controls in order to protect, help enhance the security of devices on there. So to reiterate this point, a device connecting to Azure IoT Hub, they use different communication protocols, but one thing is for sure, it is secure. That communication is secured through TLS authentication and encryption. So IoT Hub is the main ingestion point on Azure IoT. And IoT Hub has certain components that is there to assist with device security. One of it is device registry. So the model that IoT Hub works with is that for every device that connects on there, it needs to know beforehand that that device is going to connect. Why is this important? When you build your IoT and you're doing a pilot, you're working with single devices or a few hundreds of devices. When you go into manufacturing, into production, you're working with millions of devices. So sometimes you engage supply chain partners to do this. Many partners are honest, but some partners, sometimes they over-manufacture and they may side channel devices through other channels. In other words, they do unauthorized manufacturing. If you do not have controls, a way to account inside of the cloud, then devices that were not authorized to be manufactured, they get manufactured by the right manufacturers that you sanction. When they attach to the cloud, you will have no way of doing that kind of accounting. So Azure IoT Hub needs to have knowledge of what devices are going to connect, and that is done through device registry. Now, when the devices connect, there are two other questions that need to be answered. You need to know that it is the device that was meant to connect. That is attestation. You attest that this is the right device that connects. And when the device is connecting, you need to authenticate to know that it is the actual device that is connecting. So knowing that a device is going to connect is a different question to knowing that it is the device that is actually connecting. So authentication, the device that is actually connecting, and then attestation. We have three methods or three ways to do authentication on Azure IoT Hub. The first one is based on shared secrets, shared access secrets. So when you create a device registry, you can share a secret for the device that is known to the hub. And based on that secret, you can generate tokens that Azure IoT Hub can then use to trust the device, to know that it is a device, that access to that token is coming from the device. So what does that mean? On the device side, you need to protect the key that is generating that token. And that is where that secure silicon comes into place. The second method of authentication is using certificates. So certificate-based authentication. And for this particular one, the attestation mechanism is certificate thumbprints. So for this case, this is saying that if you have devices that have certificate identity on them, no matter how they got there, you can harvest this identity, generate that thumbprint, and pre-register this thumbprint in device registry. Then the thumbprints are going to be used in order to attest to the devices. So a certificate thumbprint is a digital or cryptographic summary of the certificate identity itself, small enough to uniquely identify that identity. So between the SAS method and certificate thumbprint, you see that for every device, an attestation piece needs to be registered in the cloud. This is great for brownfield deployments, where you already have deployments out there, you just need to update them to join the cloud. This is a wonderful story for that. And this is great for constrained devices. So some devices may not be able to do certificate processing, but they may have a small memory-like tamper-resistant silicon that can protect the key. So with that, you can use SAS token authentication. But the burden of registering each and every attestation piece for each of those devices, it might become a burden in the supply chain, especially if the supply chain involves many partners, where you have to transition devices from one partner to the other. Managing these secrets along the line becomes a difficulty. And that is where we introduce a certificate-based authentication. So certificate authority-based attestation. So this is still mutual authentication based on certificates, but the attestation mechanism is based on a certificate authority. So what this means is when you work with a manufacturing partner, you go through a one-time process, authorize them to manufacture the device, sign them into a trusted chain of certificates. So however many devices that they manufacture, that one authority certificate is going to be sufficient to attest to all of those devices. And when a device is connected to Azure IoT Hub, it goes through the normal TLS mutual authentication, normal TLS-based mutual authentication to attest on there. So that's authentication and device attestation. The next value that Azure IoT Hub offers is access controls onto the device. So the device has attached, is communicating well, but